So I'm looking at this page. I was looking at how I can use solar energy. So I was here on this Hn page here, and they were talking about how $200 solar self-sufficiency, and they were talking about 100-watt panels when I have a need for around 2 kilowatts of instantaneous power. So while they were talking about all the batteries, and so you have these discussions about the batteries. You have 100 ampere hour batteries, and they break down in 8 years. So what is the alternative? The alternative is pumped water storage, so potential energy. And while I was looking at that, I went around trying to find, what is the potential energy of water in a tank, how to calculate that. And so I went and ran through a few threads, and it turns out that there's this post on Quora where they calculate how much potential energy can be stored in a tank at a height h, and the tank has a height small h. So here the one thing that I realized is, why is it h by 2? It should be mass of the all the atoms in the tank plus multiplied by the gravity g, so m into g, into this height h plus the small h. Why is it h by 2? And so this is something I realized just now, and this guy's comment actually makes sense here. So at the potential energy is strictly different at each point of the tube, but you want total energy in the whole tube. At the bottom there is no energy, and at the top there is energy from the full height. So overall there is simply half of the height of the tube. Now what he has done is he's looked at the formula before and then came up with a reason that after the fact. So this seems to make sense to him, and so he just puts this as h by 2, and he says this is the reason. It's not the reason. It's not the whole reason. So definitely there is. At the bottom there is no energy, and at the top there is energy from the full height, which is true. But overall, that simply half the height of the tube is completely wrong. That's not why h by 2 comes there. Why h by 2 comes there is at the bottom there is very little energy. So let me save it to downloads. Let me just open it up and open it up with preview. Alright, so here what happens is I have, let me take this guy. Oh no, where's my pencil? Do I not have a pencil? No, alright. Let me just use this line then. Oh, damn it. So, this is the pencil. Alright, so now you have at the bottom it's 0, and as you go up the height, the potential energy keeps on increasing linearly until it reaches maximum at full height. So this is nothing but sum of n numbers. So sum of numbers up to h, and sum of numbers up to h is basically n into n plus 1 by 2, which is half. You're taking the average of all these numbers. So that average is basically n by 2. And so how do you get that? About half, so until 50%. Whatever is the excess after the 50%, you can just shift it back down here, and it would be just half the height. All the bars that I've drawn here would be exactly half the height. So that's how you get the average of h sequential numbers from 0 to h. If you want the average of numbers from 0 to 5, then it is 5 by 2, it's 2.5. And if you want from 0 to 10, the average is 10 by 2, which is 5. And so if you want the average from 0 to h, which is this, it's 0 here, it's full maximum value here, it is h by 2. So the variation, the way it changes is, here it is 0 into mass into gravity, here it is full h, the small h, into mass into gravity. So the average is, since mass and gravity are common, you can take it out. So that's why it's h by 2 and not some other factor. The potential energy varies linearly, but the only factor that changes, the mass remains the same, the gravity remains the same, the only factor that changes is height. So you can say that the change in potential energy is directly proportional to the change in height. So you can just take the average of the height values the height values, and once you take the average of the height values, you get the variation of the potential energy as well captured along with it. So that's the reason why it is h by 2. And so he completely missed the boat on that. And so now it is, so this is why h by 2. So when you actually the problem when you actually put the notation like this and then put these bars and so that this is h by 2, that is the wrong notation. That's not how you do it. What you do is you put this diagram here where you show the bars as they vary across the height, and then you say, you don't put these marks here showing that this height is the only physical volume that matters. You have to put this the bars that pop up here, you have to put these bars that show the variation of the potential energy as it's directly proportional to the height. And then you have to say, at this point you realize that the average of these numbers from 0 to h is simply h by 2, and since the potential energy is directly proportional to the height, this we can map the variation in potential, the linear variation in potential energy, to this linear variation in height. And when you add the height, take the average of the height, it is h by 2. It's not that only the bottom half or the top half of the water matters. It's just that the averages work out in that way, where half the volume does not have a significant contribution because the variation is linear. So if you look at it, the bottom half, it slowly increases from 0 to full h, and so it's equivalent to the bottom half, not to one half of the water not playing a role at all, while the remaining half of the water takes on the full weight. So full h contribution comes from the remaining half. You can think of it that way, but what is actually happening is it's a linear contribution from bottom to the top. And so that's just what I wanted to make a quick note on, and how math is completely being destroyed in our education and even in sites like Quora.